Alright, let's talk about how to find the area of a triangle, my favorite of all the shapes. Alright, so we have lots of different types of triangles. We have right triangles, we have isosceles triangles, we have equilateral triangles. They all have different kinds of angles in them, but the way to find the area is the same no matter what your triangle looks like. So let's say, for example, I have an obtuse triangle. Remember, obtuse means bigger than 90 degrees. It's got a big angle, and the other two angles in the triangle are acute, but that one big angle is what gives it its name, obtuse triangle. Now, how do I find out what the area is? We know that we want to be multiplying the base, which I'm going to go ahead and label as this one right here. If you looked at it in a different way, maybe your base would be in a different spot, but this is the way I'm looking at it, so I'm going to call that one the base. And then I'm supposed to be looking for the height, but I know that the base times the height has to make a right angle, and we've already established that that is obtuse. So how do I find it? Well, sometimes what we got to do is we have to think about what other shapes these triangles can make. I know my area formula for a parallelogram and a rectangle and a square and a rhombus. I know that those are area equals base times height. I can't really find my height here, but I also know that this is not a rectangle or a square or a parallelogram or a rhombus. But could I make it one? If I took this exact same obtuse triangle, made an exact copy, and put it right here. There's that obtuse angle again. This one could be my base, but all together now, this looks like what kind of shape? Granted, my drawing is not the best, but if you add those two exact same triangles together, you make yourself a parallelogram. We know that the base of a parallelogram right here, and we know that the height isn't something that's going to be a side dimension, but something that we have to add in so that we can make a right angle. There's my base, there's my height. I can multiply those together and find the area of that whole shape. But I don't actually want the area of that whole shape. I just want the area of this much of the shape, which is half of it. So the area formula for a triangle, while similar to that of a parallelogram, is that you have to take half of whatever the base times the height would be, and that would give you the area of the triangle. Because if I have, let's say, this right triangle right here, and I add another exact same right triangle right there, now I've made myself a rectangle. Well, area formula for a rectangle is base times height, but I only want half of that shape. The area formula for that triangle is half of whatever the base times the height would be for that whole rectangle. Let's give it a go. Here is my triangle. There's my base. My height is always going to go to the tallest point. So my height's right here making a right angle. I could not put my height here because that doesn't go up to the top of the shape. Let's give it some dimensions. My base is going to be 12 millimeters, and my height is going to be 4 millimeters. And I have to start every single area or volume problem with my formula. Look at your star chart. Right there, next to triangle, it says area equals half of the base times the height. Now, if you're more comfortable saying area equals base times height divided into two pieces, that's the same thing as taking half of it. You will not see this on the star chart. That does not mean that you can't use it. So long as you can recognize that when you're looking at the star chart and you see this formula, you can change it into that one. So it's totally your call which one you want to do. I always do the demonstration with the formula that you'll be able to see on the star chart so that it's more familiar to you. So write your area formula, then start plugging in things. Area equals half of my base, which is 12, times my height, which is 4. The nice thing about this is that these are now all multiplication. Times, times. So it doesn't actually matter if I do half times 12, or if I do half times 4, or if I do 12 times 4 and then times 1/2. Any which way I do it, it will still give me the same answer. I like to always take a half of the larger number, provided it wouldn't change it into a decimal, because that shrinks it down and I can see my multiplication problem a little bit better. Maybe I don't know my 12s tables as well, but I know my 6 tables. That's just my personal strategy. If you want to do half of 4 is 2 and then multiply that times 12, you go for it. Either way, you're going to get 24 is your area. Don't forget your units. Always need those units. Area equals 24. We're talking about millimeters. 24 millimeters. And we did millimeters times millimeters. So my area will always have my units in with an exponent of 2 or written out as 24 squared millimeters. Let's try another one. The nice thing about a right triangle is it already has that right angle. You can have your base and your height. Write your area formula. Area equals 1/2 of the base times the height. Area equals half of 3 times 5. They're not always going to be whole numbers. That's okay. You can choose. I think I'm going to do this one first. 3 times 5 is 15. I'm looking for whatever half of 15 is. That's the same as saying 15 divided by 2, if you want to do it anyway. Or I like to think of 15 as like 14 plus 1. That's the same thing as 15. And I can divide both of those in 2. Half of 14 is 7. Half of 1 is 1/2. My answer is that the area equals 7.5. Oh, notice, I didn't write units there. I don't have inches or feet or miles or whatever. So if I don't have units there, you're actually going to write the word units. That counts as your units. And since it's area, units to the power of 2. There's my answer. If you have a triangle, that gives you some information. Let's say my area equals 144 feet squared. You can use algebra to find that missing height. So surprising, bet you'll never guess what the first step is. Oh, it's to write your area formula. Area equals 1/2 of the base times the height. Area equals 1/2 of 12 times, I don't know what the height is. Oh, but I did know what the area was, so that was my bad. I'm going to write it in as 144. Now, I know that some of you are like, ugh, I can do this in my head. Why am I writing this out? I promise you, you're writing it out because the most common mistake is that you think you can do it in your head and you would do 144 divided by 12. Oh, the answer is 12. Yay! I'm going to circle the multiple choice answer that's there as a trick because I forgot about the half. You have to actually go through and write it out because you will forget steps otherwise. Like, first of all, I'm going to find out what's half of 12. It's 6. 6 times the height is 144. Don't know what that is yet. Since those are being multiplied, I'm going to divide. I really like to use the simplifying before I put it into the long division house strategy. I see that these are both even numbers. I'm going to divide them both by 2. 144 divided by 2, well, 14 divided by 2 is 7, and 4 divided by 2 is 2. That's 72. 6 divided by 2 is 3. 7 plus 2 is 7, 8, 9. Ooh, okay. Since that sum, that digital sum, is a multiple of 3, I know that it's going to evenly divide by 3, which is really exciting because I won't have any decimals. I don't know off the top of my head what it is, though, so I'm going to put it into a long division house. 3 goes into 7. Well, if I have 7 dots, I can make 2 groups of 3. All right, so it goes in 2 times. 3 times with a remainder of 1. Now, if I have 12 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can make how many groups of 3? 1, 2, 3, 4 groups of 3 with no remainder. That means that my answer is 24. My height equals 24. Height is one dimension, so it should not have an exponent on the units. It's just 24 feet. Ta-da! That's how you find the area or the missing variable when you're talking about the area of a triangle.